Hello all, myself Dr. M. Laxmidevi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. In this video lecture, we are going to see some of the programs based on user-defined functions in C programming. So, we have discussed in order to go through the concept of user-defined functions. So, you can go through my previous video lecture. Here in this video lecture, we'll write the programs based on user-defined functions. So what is a function first? So let us see in brief. So functions are nothing but a group of statements, or you can say that it is a block of code which is written. It is a block of code, or you can say that reusable code. So which is written to perform a specific task. So in order to functions perform, so with the help of functions, we can reuse the code. And also it increases the modularity of the programming. So functions, they enable us for reusability and also modularity. And with the help of this, code optimization is also achieved. So that means length of the program is reduced. So there is no need to repeat the certain set of statements. So we can group them together into a function. So in this video lecture, we'll see some of the programs based on user-defined functions. The first one is the program to check if the entered number is prime number or not. Next one is to check whether the given number is a strong number or not. The next one is whether the given number is a perfect number or not. Next program we'll write to print Fibonacci series using user-defined functions. And the next program is to find the average of two integers by using user-defined functions. And the next one is to display the multiplication table of an integer number using user-defined functions. So, what is function? Function is self-contained block or a subprogram of one or more statements that perform a specific task or special task when it is called. So, it provides modularity and code reusability. So generally we have two types of functions, library functions, and the next one is user-defined functions. Library functions, these are predefined functions. So these are predefined, or you can say that these are built-in functions which are available. So you cannot change the meaning of these functions. So example of library functions are printf function. So printf, next one is scanf function, and then these are defined in the header files. The other functions like string related functions are strcat, then strcpy, etc. So there are string related functions also, and then puts and gets functions. So these are library functions which are predefined. We cannot change the meaning of these functions. Then next one is user defined functions. User defined function example is main function here. So main function, we define this main function. So user defined functions are nothing but these are the functions which are defined by the user or programmer, you can say. So there are basic elements of user defined functions. The first one is function prototype, next one is function definition, and the last one is function call. First one, function prototype. So function prototype is nothing but it is a statement which acts as forward declaration. So this is the syntax of function prototype, where it should have a return type, then function name, and then we need to have the parameters. So based on number of parameters, so these are the numbers, and at the end we need to put a semicolon. So example is, so here int is the return type, abc is the name of the function, and int is the data type, and a is the parameter. And here we have, if we have two parameters, then we need to have the data type and the parameter name, the data type and parameter name. This is another example, or you can skip this name and directly write without the name, just data type is also sufficient. Next one is function definition. So these are the set of statements where we actually define the function for the purpose for which it has been written for. So syntax is return type, function name, then data type, and then parameter name. So inside the curly braces, so this is the block of code, or body of the function which is written. Next, function call. So in order to call the function, definition is invoked only when it is called. So that is called as function call. So let us see these different elements of function, user-defined functions with the help of programs. So first one is program to find whether the given number is prime number or not. So we know that any number is a prime number if it has only two divisors. So for example, consider 3. 3 is a prime number. Why? Because it has exactly two divisors, 1 and 3. The number 1 and the number itself. So 2 is also prime number. Next, 5 is also a prime number. 7 is also prime number. But 4 is not a prime number because it has it has the divisors 1, 2 and 4. So in addition to 1 and 4, we have other divisor also, that is 2. So therefore this is not a prime number. Now we'll write the program to check whether the given number is prime or not using user-defined functions. So this is the main function. So inside the main function, we have declared two integer variables. So one is num and the other one is result, res is equal to 0. So with the help of printf function, so here when the program is executed, so this will be displayed on the screen or monitor, enter the number, and then we need to read the number. To check whether it is prime or num by using scanf function. So scanf, the syntax for scanf is, so in double quotes you need to write the format specifier and then comma separated by the address where this num value is to be stored. So now we are calling the function. So this is the function call. Name of the function is, so this is the function call. This is how we need to call the function. So name of the function, and then inside this we need to pass the argument. So we are passing only one argument. So based upon whether we are passing the arguments, so we have types of functions, function with argument, function without argument also, and it has return type also. So based on this also we have two types of functions. So functions with return type, function without return type. So totally we have different types of functions with argument that we'll see later on. So first we'll see this program. So here when compiler sees this line, so function is transferred here. The control is transferred here. So this is the function which we have defined. This is function definition. So here we have defined the function. This is how we define the function. Return type, the name of the function. Inside this, we need to write the data type and the parameter name. So inside the function, so we have written the definition for this function to check whether the given number is prime or not. So we have declared two integer variables, I and c. C we have assigned a value 0. Now here we have written a for loop. For loop starts from, the looping variable is I. So it starts from I is equal to 1, and this loop will repeat till it achieves this condition, I is less than or equal to n. So whatever value we are passing here, num value which we have passed, suppose we are passing 5 here. So that value is assigned to n. Now n is also equal to 5. So this loop will repeat for 5 times. So then this is the update expression we need to write in the for loop. So the condition we are checking here is if n mod I, so that means the given number, this mod I, that means I value is iterating from 1 to 5, 1 to n. If this is equal to 0, then this is a prime, then c value will be incremented by 1. C++ means it is same as c is equal to c plus 1. So initially we have initialized it, c is equal to 0. So 5 mod 1 is equal to 0. So condition is true. So c value is equal to 1 now. Now in the next iteration, next I value is incremented by 2. So 5 mod 2 is equal to, this is equal to 0. This condition is false. So c value is not incremented. So it will not execute this statement. Then again I value is incremented by 1. 5 mod 3 is equal to 0. So this is also false. This is also false. So c value will be 1. Next 5 mod 4 is equal to 0. This is also false. Next 5 mod 5 is equal to 0. This condition is true here. So c value is incremented by 1 now. Now c is equal to 2. So here we have written if else condition. If C is equal to 2, so now we got the condition as C is equal to 2 here. So we are comparing the value of C with 2. So this is comparison. So we are equality operator. We are comparing the value of C and 2. So in C we have the value 2. 2 is equal to 2. So this condition is true. So therefore it will return a value 1. So since next again after this condition, control is again transferred to the line, again transferred to this line. Now RES is equal to 1 now for the given value of n. So RES is equal to 1. So now the value which is there in RES, so that is compared with 1. So 1 is equal to 1, this condition is true. So therefore the given number is a prime number. So therefore 5 is a prime number, you can say. So in this way this program is executed. So else if you pass any other number, you will get that the given number is, if you pass any even number, you will get that that number is not a prime number. So this is how we can write the program to check whether the given number is prime or not using user-defined functions. So what we have done here is actually, so we are passing the given number to the function as argument. So and then inside this function, so we have written the logic to increase the value of the count if the number is divisible by 1, 2, 3 and so on up to 5. So then if count value is equal to 2, the given number is a prime number. If count value is more than 2, then it will return a value 0 and then we can say that that number is not a prime number. So these are the two test cases which we have evaluated for this program. So in the first test case, so we have entered a number 56. So 56 is not a prime number because it is divisible by 1 and the number itself, and also the other numbers, it is also divisible by 2. So therefore we get the answer as 56 is not a prime number. Next, when you enter the number 3, so it gives the answer as the output as 3 is a prime number. So in this way we can write the program to check whether the given number is prime or not. Next program is to check whether the given number is strong number or not. Now first let us see what is a strong number. So strong number, consider the number 145. So given number is a strong number if this condition is satisfied. So condition is sum of the factorial of individual digits of the number. So 145 we can write it as, so if this condition is satisfied, so if 145 is equal to 1 factorial plus 4 factorial plus 5 factorial, then we can say that if it is true, then it is a strong number. Else if this is not equal to this condition, then it is not a strong number. Now we will write the program for this. So what we have written, so this is the int main function. So in when we are writing user defined functions, so this is user defined function where we have written two user defined functions. One is to find the factorial of the given number and the other is to check whether the given number is strong number or not. So two functions we have written here, two user defined functions. So now let us see how the program is written. So first we have declared two integer variables n and res. And then n value is stored in the variable at the address specified by ampersand n. So next res is equal to, this is a function call. So we are calling the function is strong and then we are passing the value of n to check whether n is strong number or not. Next when it says control is transferred here. So this function has return type and it also takes the parameters also. So it is a function with argument and with return type also. Inside the function we have defined two integer variables, sum and num. Sum is assigned a value 0 and num is equal to the value n. Next, this condition we are checking, while num is not equal to 0, sum is equal to sum plus factorial of num mod 10. Suppose we have given the number as 145. So that so this is num value. So now n is also equal to 145. So n is 145, num value is also equal to 145 which the user has given. So that same value is assigned to n. So this n is assigned to num here. So n is also equal to 145. While num is not equal to, so inside this we have assigned num is equal to n. So num is equal to 145. Now first it will check. So initially sum value is equal to 0. So sum is equal to sum plus. So here again we have called a function. So whenever the compiler says this line, control is transferred here. So it will call the function factorial of int n. So it will pass this argument. Suppose we have passed 145 here. Num is equal to 145. 145 mod 10. So value of this is, in order to separate the last digit, we generally divide it by 10 and get the remainder. So remainder is 5. So factorial of this, you get it as 5. So there is a function call here. So here n value is equal to 5 now. So n is equal to 5. So there is a loop written here. So which goes on multiplying the numbers from 1 to 5. So initially for I is equal to 1, so factorial is equal to 1, 1 into 1. Next in the second iteration, I is equal to 2 now. Now factorial is equal to 1 into 2. Third iteration, factorial is equal to this previous value which is there. So that into 3. So this is I value which goes on iterate, which is going on increasing, updating. Next factorial is equal to, so previous value is 6, 6 into 4. Next factorial is equal to 24 into 5. So this comes out to be 120. So return fact that 120 value which is calculated here. So that is returned here because it has a return type. Now again control is transferred here where it has left this block, left this function. So now sum value is equal to 120. So sum is equal to 120 plus. Now again it will, before checking the condition, now sum value is equal to 120 now because return type is, because here the output of this is, because when we call this function, so this is a function call, the output of this is 120. So 0 plus 120 is equal to 120. So sum is equal to 120 now. Now this line will be repeated. This line is executed now. So num is equal to num. So num value is equal to 145 divided by 10. So it is equal to 14. So in this way, so this is with this function. Now next value which is passed here to factorial to this factorial function is 4. So it will calculate factorial of 4 now because 14 mod 10 is equal to 4. So 4 factorial is calculated and that value is returned again here. So 4 factorial is equal to 24 now. So initially sum value is 20. 120 plus 24 is equal to 144. Again 14 divided by 10 is 1. So this condition becomes 1 is not equal to 0, that is true. So here again num mod 10 is equal to, so 1 value is passed now, factorial of 1 is 1 only. So that is now sum value is equal to 1 plus 144. So which is equal to 145. Sum is equal to 145 and num is equal to, now when you divide this, you will get 0 here. So therefore this condition becomes false. So it will come out of the while loop and sum is equal to n we are checking. Sum value is 145 and n value is also equal to 145. So n is equal to 145 and sum is equal to 145. So if this condition becomes true, so therefore return 1. It will return a value 1 to the calling function. So res is equal to 1 now. So here we are checking the condition, res is equal to 1. So therefore we can, here printf statement is %d is a strong number. So therefore the given value of n is the n value is a strong number, else it is not a strong number. So in this way, in order to check whether the given number is strong number or not, we have written two functions, two user defined functions, one to calculate the factorial and other to calculate the sum of the digits. So when we two test cases are evaluated here, so when we enter the number as 145, we can say the output is 145 is a strong number because this condition is true here. So when we enter the number 3, so we get the output as 3 is not a strong number because, so 3 is equal to, so 3 factorial is not equal to this. Therefore this condition is, this is not equal to 3 factorial. Therefore this is not a strong number. So in this way we have written the program. Next number is to check whether the given number is perfect number or not. So what is a perfect number? Perfect number is For example, consider the number 6. So 6, to check whether the given number is perfect number or not. So we need to find out the divisors of this number. So that is divisors of this as 1, 2 and 3, and excluding the number itself. 6 is also a divisor of 6 only, but we need not include that 6. So sum of these divisors should be equal to the number. So 1 plus 2 is 3, 3 plus 3 is equal to 6. So this condition is true, so therefore it is a strong perfect number. If this condition is true, the given number is a perfect number. Consider any other number, suppose 23. So 23, divisors of 23 are 1, 23. So 1 plus 23 is not, so we should not include this number. So we can say that the given number is a perfect number if the divisors of the given number, excluding the number itself, if the sum of divisors of this number excluding the number is equal to the number itself. So that is a perfect number. So we have written, to check whether the given number is perfect number or not, we have written user defined functions. So first, this is the header file. Next one is, this is the function prototype. So we need to write the function prototype. This is the function prototype. Function prototype is written to check whether the function definition is, whether the function is defined correctly or not. So this statement acts as forward declaration. Return type is integer. Name of the function is perfect, and it takes integer type argument. And then main function. Inside the main function, we have declared two integer variables, num and res. And then num value, which is entered by the user. So that is stored in the variable num at the address specified by num at this particular address. So now this function is called here. So is perfect num. So this function we have written at the end of the main function. After the main function, we have written this. So whenever we are writing the function definition afterwards, so therefore we need to write the function prototype. So is perfect number. This is the function definition, and it has a return type also. So return value is stored in the variable res. Now let us see how we have written the function. So return type, integer, name of the function, and then data type, and then parameter name. So num, so whatever the value which is entered by the user, so that is stored in the variable num. Suppose the user is entering 6 here. Suppose the user is entering num value of 6. So same value is copied here also. This is a local variable which exists in this block itself. So num is equal to 6 now. So num value is equal to 6. So we have declared two integer variables, I and sum. So sum is assigned a value 0. So there is a loop written here for I is equal to 1 to less than num. Suppose num is equal to 6 here. So this loop will repeat 5 times from 1 to 5. So next, after checking this condition, some value is if this condition is true, some value is incremented by I. So let us see how it is done. So num value is equal to 6 now. So if 6 mod I, that is 1 is equal to, so this is the first iteration. If this is equal to 0, so condition is true here. So therefore some value is incremented. So some value is sum plus, initially some value is 0. Sum plus I is equal to 1. So some value is equal to 1 now. Next, in the second iteration, again it will check the condition. Now 6 mod 2 is equal to 0 or not. So this is also true. So therefore now sum value is equal to, sum is equal to 1 plus I. So I is equal to 2. So this is equal to 3 now. Next, in the next iteration, third iteration, iteration 3. So 6 mod 3 is equal to 0. This condition is true because when we divide this 6 by 3, you will get a remainder as 0. So this condition is true. So therefore sum value is, already sum has a value 3. So 3 plus this 3 is equal to 6 now. So next, 6 mod 4 is equal to 0. This condition is false. So some value will not be incremented. Next, when 6 mod 5, it will check 6 mod 5 is equal to 0 in the next iteration. So this is 4, this is 5. This is also false. So therefore some value is not updated here. So now so when this condition becomes false, it comes out of this loop. and it will check this condition. If sum is equal to num here, sum value is equal to 6. So this value and num value which we have entered, so those two values are compared. These two are equal means condition is true. So therefore it will return a value 1. So return 1 means, so it has a return type. So it will return something. So that return value is stored in the variable res. So now res has a value 1. So this 1, if res is equal to 1, then it is to be printed that percentage, the given value is the given number is a perfect number. So we have evaluated two test cases. So when we run the program, so in the first test case, we are given the number 23 and the output is, we are getting as 23 is not a perfect number. Then when we enter the number 6, in the second test case, the output is 6 is a perfect number. So in this case, in this way, we can write the program to check whether the given number is perfect number or not. Next program is to print Fibonacci series. Now what is Fibonacci series is, this is a series of numbers where the next number is the addition of the previous two numbers. So next number you get is the addition of previous two numbers. So suppose 0 and 1, we have next number will be 1 and the next number will be addition of these two numbers 2. Next number is equal to addition of these two. 2 plus 1 is equal to 3. So in this way, this is a Fibonacci series. So for this we are going to write the program by using C program in C language. So here we have included the header file stdio.h header file. So this is a function, a definition we have written to find whether the given number is, to find the Fibonacci series. So it takes one argument and it is a function which does not have any return type, but it takes one argument. First, let us see the main function here. So inside the main function, we have declared a variable num and printf function enter the number of elements more than 2. So that num will be stored in the variable num at the address specified by this ampersand of num. So now this is a function called generate Fibonacci. Num value is passed here. So control is transferred to this. So here we have directly written the function definition after the header file. So therefore no need of function prototype. So directly we have written the function definition. So inside the function, so we have declared three integer variables a, b, c. So these are the three integer variables and one more integer variable we have declared as ELE. So this ELE is equal to, when at the starting a is equal to 0 and b is assigned a value of 1 and 0 and 1, next value is equal to c is equal to a plus b. So 0 plus 1 is equal to 1. So 0, 1 and then c we need to print. So this is a, b and c. Now what we are doing here is, so first in this printf statement we are printing the values of a and b. So 0 and 1 will be printed. Next c value is calculated. C is equal to a plus b. So ELE is an integer variable. It is assigned a value 3. So while this condition becomes false, this condition is true. So these set of statements which are there in the while loop, they will be executed. So ELE is assigned a value 3. So 3 is less than or equal to, suppose we have entered the number as 5. So 5 is nothing but the number we need to enter. Suppose we have entered the 5, number as 5. So this 5 indicates that how many elements are to be printed. So 5 means 0, 1, 2, 3, 4 and 5. Next number is 3 plus 2, 5. So till this, the value will be printed. So 3 is less than or equal to 5. This condition is true. So it will print C value, C which we have already calculated. So 0, 1, now C value is equal to 1. So that will be printed. Next ELE is incremented by 1. So ELE is equal to 4 now. Now in order to get the next number, so we need to add, what we have to do here is, suppose A value is 0 and B value is 1, C value is equal to 1. So what we need to do here is, next A and B values have to be, so this should be A in the next iteration, this should be B. So B value is assigned to A and then C value is assigned to B. Now again we have to calculate the value of C. C is equal to A plus B. So that logic we have written here. A is equal to B is equal to C, and C is equal to A plus B. So this will go on repeating till this condition becomes false. So once this condition becomes false, so 5, it will repeat for 4 also. Yearly value is incremented by 1. Next, when it will become 4, 4 is less than or equal to 5. Again, so next value also will be printed 0, 1, 1. So 1 plus 1 is 2. So this is 3. So next, when 5 is less than or 5, for 5 also it will be executed. These statements will be executed. When yearly value is equal to 6, so these set of statements will no longer be repeated. Now when you execute this program, when we run the program, enter the number of elements more than 2. Suppose we have entered the number as 5. So it will print this as the Fibonacci series. So 1, 2, 3, 4 and 5. So 5 elements are to be printed here. So A is 0, 1, 1, 2 and 3. So up to 5. Suppose if we give the number of elements as 7, 2 more elements will be added. 1, 2, 3, 4, 5, 6. So 3 plus 2 is 5. Next 3 plus 5 is equal to 8. So in this way, this is the Fibonacci series which has been generated for the element count as 7. So when we give the element count as 5, so this is the Fibonacci series 0, 1, 1, 2 and 3. So in this way, we can write the program to generate Fibonacci series. Now let us write a program to find the sum and average of two numbers by using user-defined functions. So we know that it is a simple program. A is equal to, in order to find out the sum and average of two integer numbers, we are writing a function called as sum and one more function average. So we need to write we are writing two functions here. One user-defined function is written to calculate the sum, and other user-defined function is written to calculate the average. So this sum and average both are the function type is function with arguments and with return type also. Function with argument and with return type. So let us see the program first. So first we have declared the function. This is function prototype. Return type is integer. Name of the function is sum, and it accepts two integer arguments. Next, the average is also, name of the function is average, avg. Return type is float and it accepts two integers. So at the end we need to put a semicolon. Inside the main function we have declared two integer variables num1 and num2 and one more integer variable s. So float variable average. So here we are storing the values of two numbers which need to be added at the address specified by num1 and num2. So now we are calling the function to calculate the sum, and since it has return type, so value which is returned, that is stored in the variable s here. So we are passing the two values, two positive integers num1 and num2. Next we need to define the function. So its function is defined here. So this is the function definition to calculate the sum. So return type, sum, name of the function, data type and then variable name. So since we require two values, so therefore two parameters are there here. Along with the data type, we need to mention the name of the parameter also. So these are local variables, x and y are local variables to this function, and inside this one more variable sum we have declared as integer variable. Sum is equal to x plus y. So we are returning the value of sum. So that sum value which is returned, that is assigned to this variable s. Next, in this line we are printing the value of s value. So next, this is a function call to calculate the average. So this is a function definition to calculate the average of two numbers. So two integers we are passing. Inside this we have declared one more integer variable, one more float variable average. So if you directly write x plus y, so this is a formula to calculate the average. Since x and y are integer type, so therefore we need to typecast it. So any one variable can be typecasted. So typecasting is converting this to converting integer type to float type. Otherwise you will get the result in integer only. So float of x plus y divide by 2. So therefore this we need to return. So this will return a float value. So that float value is assigned to this variable average. So that value we are printing. So in this way, when you execute this program, and if we enter the two integers as 35 and 46, so sum is printed as 81 and average is printed as 40.5. Now let us see one more program to print the multiplication table of an integer number. So it's a very simple program by using user-defined functions to print the multiplication table. So multiplication table, so we are printing from any number. Suppose number is equal to 5. So 5 into 1 is equal to 5 till 10. So we are starting from 1 and the last value is equal to 10. So this we can write by using for loop. For this we have implemented this program by using user-defined functions. So this is the function prototype. It does not return anything, name of the function and what argument it takes, what type of argument it takes. Next, main function, we have declared one integer variable and then the number value for which we need to find out, for which we need to write the multiplication table. So that number is stored in the variable num at the address specified by this variable ampersand m. Then multiplication table of the number. So this is a function call. Name of the function is print table. Num value we are passing. Suppose number is equal to 5. So that value is passed here num, and that value is assigned to this variable. Same variable we have taken here, or you can take any other variable also. Inside this function, so when there is a function call, control is transferred here. So inside this, these statements are executed. So int I, one integer variable. So that is a looping variable which we have taken. I is equal to 1 and this will repeat for 10 times. So I is equal to 1 to, so this is I is equal to 1 and so on up to 10. So number is equal to 5. What we are printing is number into I value. So in each iteration, so first iteration, I value is equal to 1. Next iteration, I is equal to 2 and so on. So in this way, value of this will be printed 5. The next is 10, 15 and so on. So when we run this program, on the screen we'll get enter the number as, so the number which is entered by the user is 5. So it will print multiplication table of 5 is from 1 to 10 it will print. So 5, 10, 15, 20, 25 and so on up to 50. So you can modify this program also in order to print the multiplication table from 1 to 20 also in any way the user wants or the programmer wants. So thus these are the programs which we have written for you by using user-defined functions. So in the coming video lectures, we'll discuss some more programs based on some other concepts of C programming. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.